Okay, let's then discuss precision seen through significant figures. So, what are significant figures? Significant figures are the total number of digits that are significant in a measurement. So, if you have greater number of significant figures, that's a good thing because that means that you have a higher level of precision and accuracy in that particular measurement. Realize when you're making measurement, the results that you get that can only be as reliable as the least precise measurement, and that's important to realize. What I mean by that is that if I am taking the time to have my volumes measured using a burette that can read up to second decimal place, but then I make a measurement all of a sudden with just a very coarse pipette, then that coarse pipette is going to make the rest of the result less precise. There are certain rules that one needs to realize before you can claim how many significant figures should be present. Well, first of all, any non-zero digit, any number, will be considered a significant number. But when you have zeros, that's when the rules are a little bit different. So that's what I want to go over. Zeros that are in the middle of a number are always significant. So for example, if you have something like maybe 101, that will have three significant figures, three sig figs. On the other hand, if you have something like zeros that are in the beginning of the number, so let's say you have 0025, that contains only two sig figs because these leading two zeros, they mean nothing actually. They are not significant at all. Zeros at the end of a number, which are trailing zeros, and if they are after the period, those are significant. So for example, if you have 10, which is from a burette, compare that to 10.0 and compare that to just 10. Now the first one that I have that has the maximum number of significant figures, it has like 4 significant figures. The second one that has 3, and 10 has maximum 2 significant figures. Zeros at the end of a number and before a period may or may not be significant. What I mean by that is, for example, if you have the number 10, this can have either 1 or 2 significant figures, and what that means is that if you're considering only this item, that will be only 1 significant figure, but if you count 1 as well as 0, that will be a total of 2 significant figures. And a good way, if you have a number like this, because it is dependent on the measurement, what you can do is you can simply convert it into the scientific notation. So for example, 10 can be written as 1.0 times 10 to the power of 1, and in that case you would say that it has 2 significant figures. But if you're writing that as 1 times 10 to the power of 1, then you're going to count only this 1, and that would mean that it has only 1 significant figure. Let's go forward. The question is, how many significant figures are present in all of these? So again, I'm going to pick any 2 perhaps, and then it'll be your responsibility to go over the remaining. Let's go one by one. So if you consider the first one, this has 0.000459. Really, if you think about it, the first 3 zeros, which are leading zeros, are only providing the place for the decimal. So these are not going to count, and the number of sig figs that this number has is just 3, because you can write that number as 4.59 times 10 to the power of negative 4. And since there are only 3 irrelevant digits, 4, 5, and 9. So the total number of significant figures are just 3. Let's consider 36450. In this case, you can have 4 or 5. If you count 3, 6, 4, and 5. That will be a total of 4 significant figures. If you include the 0, which is a trailing 0, you would say that there are 5 significant figures. If you consider the last one, in this case, you do have 5 significant figures because the last 0, which is a trailing 0, will count. Now, when you're making measurements, depending on whether it's a multiplication or division or whether it's an addition or a subtraction, rules are different. So, for example, in this case, I want to figure out the mileage for a particular gas that covered 278 miles in 11.70 gallons. And if you think about it, 278 has 3 significant figures, whereas 11.70 has 4 significant figures. And so when you carry out that division, you end up with 23.8. You can only report significant figures corresponding to the least significant figure of the two. In this case, since the numerator has the less of the two, you can report only 3 significant figures for this particular calculation. On the other hand, if you had, let's before we go to the addition and subtraction, let's perhaps go over a couple examples. So if you have 238.5 and 79, and you want to carry out that multiplication, that mathematical operation, the question is how would you report the final answer? So on my calculator, I'm going to plug in 238.5 times 70, and the answer that I'm getting here is where did my text go? Is 18841.5. But now when you count the significant figures, there are 1, 2, 3, 4 significant figures in the first number. There are only 2 significant figures in the second number, so I should be reporting only 2 significant figures over here. So what do we do now? We will basically see the number. We will start counting from the left hand side, and it's 1.88. If I write it in the scientific notation, it will be 1.88441.5 times whoa, extra decimal there, 10 to the power of, it moved 4 places, right? So if you had to write this in a format such that it reflects only 2 sig figs, you're going to say that it is going to be 1.9 times 10 to the power of 4. That means you're going to simply have to round up the 1.88415 such that it reflects 2 sig figs. Let's do another one just for the sake of argument. Perhaps I can pick, let's do this one. We have 4 significant figures for, or maybe let's do a division because we already did a multiplication. So we have 2 significant figures for the 12, and we have 4 significant figures for the second number. What that means is that when we carry out the math, so when I'm doing 12 divided by 0.1272, I'm getting an answer 94. Let's write that, 94.339, and then it just goes on 622 blah 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 blah. Since I'm supposed to report it only in 2 significant figures, again I'm going to start from the left hand side and I'm going to stop after the second decimal place. But since, second significant figure. So what I'm going to do is I'm going to just check right after decimal what that number is. Since that number is 3, which is less than 5, we will need to round it down, and we will report this answer as 94, that as our final answer. Things are a little bit different when it's the case of an addition or subtraction. In that case, the answer does not have more digits to the right hand side of the decimal than any of the original number. What I mean by that is that if you have, let's say, 3.18 and you're adding 0.01315, now you have more number of digits. There are like 5 decimal places past the decimal point, whereas there are only 2 past the decimal point for the other number. So now when you add the two, while your answer should look like 3.19315, you report it only as 3.19 because that's the lower number of decimal places past the decimal point of the two numbers. So you're going to report this answer as 3.19. Let's see if we can practice. So if you add, for instance, 238.5 and you add 79 to that, do you think you should have a decimal or no? Absolutely, because in this case when you add the two, it comes out to be 317.5, and there are no decimal places past in case of 79, hence you should not report any decimal place in this case, so you should report this answer as 318. Let's report it as 318 because you will be rounding it up. Let's try another one, maybe a subtraction. So 12.3, and I'm going to subtract out 0.1272. Comes out to be, the answer comes out to be 12.1728. Again, if you think about the decimal places, there is only one decimal place that you have in case of 12.3, so that is what you want to stick to. So you're going to report this answer as 12.2, rounding up that 17 to 12.2. That will be your final answer. And that's what I'm going to review very quickly, which is the rules to round up and round down. Whenever you have the digit, if it is more than 5, you round up. If the first digit, that needs to be removed. If that is more than 5, then you round up, and if it is less than 5, then you round down. What that means is that you leave that number as is. So please realize that you are only supposed to round off the final numbers. You do not round off any intermediate calculations. So for example, if the question says round off each of the following measurements, 3.774499 liters to 4 sig figs. So again, you're going to begin from the left hand side. 1, 2, 3, 4. So you see what's coming next. Since it's 4, you basically say that this is going to be just 3.774 liters is your answer. 255.0974 up to 3 sig figs. And so again, you're going to start from the left hand side and count only 3. That will come out to be 255 Kelvin, because after the decimal the number is 0, which is going to be less than 5, and hence you round it down in this case. Finally, the last answer will come out to be 55.27 because you need 4 significant figures in this case. Okay. So if the question is which of the following is precise but not accurate, hopefully you can see that it is going to be A. We just discussed that a couple minutes ago. B is the case of precise and accurate, and C is the case of neither precise nor accurate. All right. Let's then discuss measurements and units, and I'll spend some time on the dimensional analysis method as well, so we understand what's going on. So